Hello, Professor. This is my exam to review, not my best performance. I already have some information written out, because I can't think off the top of my head. But, so, the questions I got wrong, or the ones I got the most wrong on, was question 4 and 5. And then I'll cover 5 in a little bit. So the first, it was consider, the double integral of x times e to the xy dA over, and then here we have the region of xy as 0, or as x is from 0 to 1, and then y is from -1 to 1. And so here, A was right both options, and here we have, I did get this one right in my mind. I don't know what, I just can't explain what was going through my mind as to why I highlighted this, because this is the part that I didn't write out on the exam, and so I didn't write the dy, dx, and then literally the whole function dy, dx. So here are both of the options. We have 0, we have as, x of 0 goes to x of -1, and as y of -1 goes to +1. And so, and then ultimately I had to decide on dy dx, because when deriving y first, we can use u sub, and this allows us to get e to the u, which we can easily integrate because e to the u is e to the u. And so this is now where we evaluate, and oh my god, I'm a little mad at myself just because I was so close yet so far. And so here we start off with, we take u sub, I use u sub, we're going to do x and y, du, and then the y, we do, like, because we're deriving by y first, we get x dx. And then this then translates, or turns into, whenever x equals 1, x equals 0, y equals -1, y equals 1. We have it x to the x times e to the u. And then this turns, we see this as, let me see. And because there's an x, I'm also going based off the notes that I had. And then your notes. I really appreciate that you make a lot of notes on, what I did wrong. And so because we have an x, we know that it turns into eu du. And then dx. Because we can't forget about the dx. We still have that 1, -1, x equals 1, x equals 0. And so then we plug this back in exy, which turns into e1x minus e to the -1x. I know, like, I don't have to put the ones there, I acknowledge that, but just for, like, just keep it in my head. And so then that turns, we have x equals 1 as x equals 0. We have e to the x minus e to the -x. I made the mistake. I didn't. I put, hold on. I put e1 to e0, which is incorrect because it should have been e1 minus e to the -1 minus e to the 0. And if I remember correctly, I think e to the 0 goes to 1, but I'm going to double check just to be sure. Yeah, so this is, and then a 0 can't be negative, so this turns into 0. And then we have e to the 1. Let's see, e to the 1. Oh, I need a scientific calculator for this. Oh my gosh, I really do appreciate that you write notes. Because it just, like, I realized what I did wrong. And I continue to gap because e to the -1. Hold on, I like to use Desmos too. Plug that into my calculator, and I got 2.35, oh my god. 2.3504, and it goes on. But I know you said, I don't know why I put the plus C2. I'm not looking at it, I think I got lost, but you did say no decimals. So the answer is e to the 1, e to the -1. And then this is our answer for 4. So close yet so far. Let's see. So I think if I just actually walked myself through this and took my time with it, even though I feel like I did, I don't know. I always choke. I'm not proud of that. But yes, that's that part. And then for D, I do have that like here. Let me move that up here. I thought I was going to take up much more space. Okay. Now D. Okay, and then now for D, let's switch back to gray. And so after looking back at my notes, the fraction that I would multiply to get the average value would ultimately be 1/2. And I know this because average value equals 1 area times r, r, f, x, y, dA. It's messy handwriting, ignore that. And so in this specific situation, because to get the area we have to multiply width times height. And so for x we have 1, 0 equals 1, because we subtract, then we have 1 minus -1, 1 is equals 2. And so for area, we have 1 times 2 equals 2. So yeah, we basically multiply 1/2 times e to the, what did I have? 1 to the -1. And yeah. Okay, and here we have question 5. And the question for this one was, the region R is bounded by graphs y equals 2x and y equals 1/2 x squared. And so we have, I did get the first 2 parts right, but then when it came to solving it, I completely choked. And so I'll just copy that down here. So we have 4, 0. And we know this because the graph that was given, it goes from 0, 0 to 4, 8. And so I knew since that we were looking at the x, that this was going to be 4, and this was going to be, so the x equals. And then we have y equals, luckily it was already given to us, so we have our 2x in the grand. And then down here we have y equals 1/2 x squared. And so, yeah, this is going to be the x region. So we have the 8x squared y, dy, dx. And then for it as a y region, we know that we have to convert these into x's. And so, pretty easy way of doing that. Let's see, I'll do this in the mean. So with y equal to 2x, we just divide that 2. Boom, y equal, or yeah, y over 2 equals x. And then in this case, we have y equals 1/2 x squared. We're going to just multiply that 2, which is going to equal 2y equals x squared. Square that, boom, you get the square root of 2y equals x. And so we come back over here, and then again on the graph, it shows us, oh, that is not a good graph, hold on. We see something like this. And so this is 4, 8, and this is 0, 0. So that's where I know that y equals 8 and y equals 0. And then, as a what, regular y region, we have 2 then equals the square root of 2y, and then x equals y divided by 2. We get the same thing, 8x squared times y dx dy. And in this case, I think conceptually, I like that these numbers are smaller, so I know that our answer isn't going to be too big. And then also in terms of plugging numbers in, the y divided by 2, and then the square root of 2y, I feel like that's going to complicate some things. And I can easily work with dy dx. So we're going to write that again down here, 4, 0. X squared, okay, 8x squared, y dx, dy dx. Okay, and so first step here is we're going to solve the inner integral with respect to y. And so to do that, we know that the antiderivative of this, the x is going to be treated as a constant because we're solving for y first. So we're going to have 8x squared multiplied by, this is essentially 1/2. You can divide the y by 2, but I like to do this too. I like to do this just because I feel like it's easier to understand in my mind. And so then that turns into 4x squared y squared. Boom, integrated that, and now we can plug in the 2x and the 1/2 x squared. And so we're gonna have to do this 2x 1/2 x squared. I'll this off to the side so we don't forget it. Okay, and so we're gonna have 4x squared times 2x squared minus 1x squared 1/2 x squared. We're just plugging these in. And so we see this then goes right here. We multiply the 2 and the 4, and then the x becomes squared. So we get 4x squared times 4x squared. I already see something. Minus, and then the square also goes here, and then also right here. So 4x squared, and that turns into 1/4 x to the 4th power. Yeah. And then we multiply this together. We see 16x squared minus, and then these cancel out. So then we get, boom, 16x squared minus x to the 6th power. And then now we can drop this down right here. I don't know why, but every time I redo these problems on a separate note outside of the exam, they just seem so much more easier. Like, this really wasn't that complicated. Sigh. But yeah, I have a dx here, because now we're integrating in respect to x. And to save myself the hustle, I'm going to 4 here, 0, anyway. I'm going to move the 16 outside. Oh, not 16. Okay, we're going to have x squared, and x. Now we're going to go ahead and integrate that. We're going to get 1/3 minus 1/7 x. And then, okay, wait. And this is wrong. Oop, it's 4. So this goes to 5. Okay, got myself there. That's going to be 7. And so, easy peasy, we then bring back the 16. So we get 4, 0. We get 16 over 5, x to the 5th, minus 1/7 x to the 7th power. And then now we go ahead and plug those numbers in. Oh, 4. Boom. Go ahead and plug that number in. To the 7th. 0. And then 1/7 times 0. The 7th at 0, 0, so we must cancel out the 0. Whew, and a whole lot. I'm just going to go ahead and plug that into Desmos. And because it starts getting pretty big, but I'm just 16, 3, 4. I also have my phone right next to me, so I'm doing that. And then, I hate when they're all big and nasty like this, but 10, 24 minus 1/7, 16, 384. And then we get, okay, I'm so tired. Sorry. Is there, can I, hold on. Round your answer to the 3 decimal places. Okay. Ooh. And then from Desmos, I got 936.2, and the 3 decimal places 2. And then it's 8, 5, but the 5 makes 8 round up to a 9. So, this is the answer that I should have gotten if I had taken my sweet time. But yeah, thank you for watching, Professor.